Welcome students, chapter number 11, Project Risk Management. Our today's topic is about performing quantitative risk analysis. As we discussed earlier that the project risk management has 7 processes and we already covered the first 3 processes. So today we'll see how to calculate or find out the quantitative risk analysis. Quantitative risk analysis is a method used in risk management to numerically assess the likelihood and impact of risks on a project or business. It involves assigning numerical values to risk and their potential consequences, and often using the statistical techniques and mathematical models. So we need to analyze data and the main to find out, to quantify the risks. So it often follows quantitative risk analysis, but both can be done together. And for large, complex projects involving the leading edge technologies, often requires the extensive quantitative risk analysis. The main techniques for quantitative risk analysis are decision tree analysis, simulation, and sensitivity analysis. So first we will discuss the decision trees and the expected monetary value associated with. So decision tree is a diagramming analysis technique used to help select the best course of action in situations in which future outcomes are certain. Common application of decision tree analysis involves calculating the expected monetary values. So estimated monetary value is the product of a risk event probability and the risk event's monetary value. You can draw a decision tree to help find the EMV. We will see in the practical part. And the positive and higher the numeric number results is better. So this diagram is actually shows the decision tree and expected monetary value calculations. So as you see, this is a diagram is from your book 11.7. So this figure uses the issue of which projects an organization might pursue. So there are 2 projects. So our organization needs to decide which projects should be bid. So suppose from our opening case, the Cliff Brands firm was trying to decide if it should submit a proposal for project 1 or project 2, or maybe for both the projects or neither project. The team could draw a decision tree with 2 branches as shown in the figure, project 1 and the project 2. So the firm could then calculate the expected monetary value to help make this decision. So to create a decision tree and to calculate the expected monetary value specifically, you must estimate the probabilities or chances of certain events occurring. For example, as you see in the figure, the 20% for the project number 1, the 20% probability that Cliffs Farms will win the contract for project 1, which is estimated to be worth, this is the dollar value, $300,000 in profits, the outcome of the top branch in the figure, right? Similarly, you can see for the project number 1, there is an 80% probability that the firm will not win the contract for project 1, and the outcome is estimated to be minus $40,000 into the project 1, which means that the firm will have invested $40,000 into project 1 with no reimbursement if it does not win the contract. So here, the one of the important part is that the sum of the probabilities. Now you see the probability for winning the project is 0.2 and for failing to get the project is 0.2. So 0.2 plus 0.1 will become 1. So the sum of the probabilities for outcomes for each project must equal to 1. So probabilities are actually normally determined based on the expert judgment. So in that case of our opening case study, the cliff or other people in this firm should have a sense of the likelihood of winning certain projects. Now, you can see here the probabilities and the outcomes for the second branch for the outcomes for project number 2. So it has, you can see the 3 probabilities are there. So suppose there is a 20% probability that Cliff's firm will lose $50,000. You can see with the minus sign. And also a 10% probability that it will lose $20,000 and a 70% probability that it will earn $60,000. Again, the expert would need to estimate these dollar amounts and the probabilities. So how to calculate the EMV value? If you see on the right hand side of the figure, the EMV of outcomes. So to calculate the EMV for each project, we need to multiply the probability by the outcome value for each potential outcome for each project, and then sum the results. So we can see here by multiplying the values by the probability and the cost value, we get this value, like it's $60,000. Similarly, the probability of not winning the project for number 1 multiplied by the cost value will give us this amount. And same way we get the values for all EMV values for each probability. So here we can see in the end, we need to make the sum of the respective EMV outcome values. So in this example, you can see the adding $60,000 and then at minus $32,000. So the EMV for the project 1 is $28,000. Similarly, for the project number 2, if we add all these values like minus EMV for each probability, we get the $30,000. So the project number 2 has EMV is $30,000. So how to interpret these results? Because the EMV provides an estimate for the total dollar value of a decision, you want to have a positive number. So higher the EMV, the better is the chance to get this, to select the project, to work on that project. Because the EMV is positive for both projects 1 and 2, we can see for the project number 1, it is $28,000. For the project number 2, it's $30,000. So in our case, the EMV is positive for both the project 1 and project 2. And there is a little difference, like $28,000 and $30,000. So in this situation, the Cliffs firm would expect a positive outcome from each and could bid on both the projects maybe. But in the case, if it had to choose between the 2 projects, perhaps because of some limited resources or the time constraints, so the Cliffs firm should bid on project number 2 because it has a higher EMV. So this is how we can interpret the results. So again, you can notice that if you have just look at the potential outcome of the 2 projects, like project 1 looks more appealing, you could earn how much if you select this project or win the bid for this project. It is more lucrative that you can earn $300,000 in profits from project 1, but you could only earn $60,000 for project number 2. So if Cliff were a risk seeker, he would naturally want to bid on project 1. However, there is only a 20% chance of earning the $300,000 because the high for the project number 1, the probability of not winning the project is 0.8. So there is only a 20% chance of earning this for the project number 1, as opposed to a 70% chance of earning $60,000 on project number 2. So using the EMV helps account for all possible outcomes and their probabilities of occurrences, thereby reducing the tendency to pursue overly aggressive or conservative risk strategies. Now, the second is a more sophisticated simulation, which is a more sophisticated technique for quantitative risk analysis for finding out to choose to quantify the numbers. So simulation uses a representation or model of a system to analyze the expected behavior or performance of the system. For this, we are discussing the Monte Carlo analysis. So Monte Carlo analysis simulates a model's outcome many times to provide a statistical distribution of the calculated risk. It predicts the probability of finishing by a certain date or the probability that the cost will be equal to or less than a certain value. For example, Monte Carlo analysis can determine that a project will finish by a certain date only 10% of the time and determine another date for which the project will finish 50% of the time. So in other words, the Monte Carlo analysis can predict the probability of finishing by a certain date or the probability that the cost will be equal to or less than a certain value. So you can use several different types of distribution functions when performing a Monte Carlo analysis. Let's discuss some examples. So if we want to use a Monte Carlo simulation, you must have three estimates: most likely, pessimistic, and optimistic, plus an estimate of the likelihood of the estimate being between the most likely and optimistic values. So first of all, as I tell you, first step of Monte Carlo analysis is to collect the most likely, optimistic, and pessimistic estimates for the variables in the model. For example, if you are trying to determine the likelihood of meeting project schedule, goals, the project network diagram would be your model. You would collect the most likely optimistic and pessimistic time estimates for each task. So notice that this step is similar to collecting data for performing PERT estimates. However, instead of applying the same PERT weighted average formula, you perform the following steps in a Monte Carlo simulation. So then the second point, after collecting the most likely optimistic and pessimistic estimates, the second step is to determine the probability distribution of each variable. So in this step, you have to find out what is the likelihood of a variable falling between the optimistic and most likely estimates. For example, if an expert assigned to a particular task provides a most likely estimate of 10 weeks, let's say, so an optimistic estimate of 8 weeks and a pessimistic estimate, let's say, of 15 weeks. So you can then ask about the probability of completing that task between 8 and 10 weeks. Again, the expert might respond that there is a 20% probability. The third step, select a random value based on the probability distribution for each variable. For example, using the preceding scenario, you would randomly pick a value between 8 weeks and the 10 weeks. So 20% of the time, and a value between 10 weeks and the 15 weeks, 80% of the time. Next step is to run a deterministic analysis or one pass through the model. At this step, for example, like as we discussed, one task described in the preceding scenario might have a value of 12 on the first run. All of the other tasks would also have one random value assigned to them on the first run based on their estimates and the probability distributions. Last step is to repeat steps 3 and 4 many times to obtain the probability distribution of the model's results. Here, the number of iterations actually depends on the number of variables and the degree of confidence required in the results, but it typically lies between 100 and 1000. Any value, at least 100 iterations should be there. So using the project schedule as an example, the final simulation results will show you the probability of completing the entire project within a certain time period. Now, this diagram is actually illustrates the results from a Monte Carlo based simulation of a project schedule On the left side of the diagram of a figure, you can see a chart which displaying the columns and an S-shaped curve, this shape S-shaped curves. So the height of each column here indicates how many times the project was completed in a given time interval during the simulation run, which is the sample count. So further you can see in this example, as it is mentioned, the time interval was 2 working days. Each bar represents 2 working days. And the simulation was run 250 times. As I tell you, it should be between at least 100 to 1000 iterations. And the first column, the chart on you can see the chart. The first column shows that the project was completed by January 29, only 2 times during the simulation. Here you can see. The S-shaped curve shows the cumulative probability of completing the project on or before a given date. On the right-hand side of the figure, we can see the tabular information. For example, there is a 10% probability for the project will be completed by February 8. Also, further you can see there is a 50% of chance of the probability or the chance of completion by the 17th February. And further we can see the different probabilities for the different dates. And here you can see there is a 90% chance of completion of the project by February 25. So here, this is how we can do the simulation. So, but the point is how to perform this quantitative risk analysis. We will see in our lab also. But here you can see the Microsoft Excel is a common tool for performing quantitative risk analysis. Microsoft provides examples of how to use Excel to perform Monte Carlo simulation on its website as well, and explains how several companies use Monte Carlo simulation as an important tool for decision making. So some examples are there of some companies are shown here which are using the Monte Carlo simulations. For example, the General Motors uses simulation for forecasting its net income, predicting structural costs and purchasing costs of vehicles, and determining the company's susceptibility to different kinds of risk. Another example is Eli Lilly uses simulation to determine the optimal plant capacity that should be built for developing each drug. Also, Procter & Gamble uses simulation to model foreign exchange risk. Monte Carlo simulation can also help reduce the schedule risk on agile projects as well. Now, the third one is the sensitivity analysis. Many people are familiar with using sensitivity analysis to see the effects of changing one or more variables on an outcome. For example, as it is shown here in the example, many people use it to determine what the monthly payments for a loan will be given different interest rates or periods of the loan. Also, what will your monthly mortgage payment be if you borrow maybe certain amount, let's say $1,000 for 30 years at a 6% rate. Another case, maybe what will the amount be if the interest rate is 7%? What will the payment be if you decide to pay off the loan in 15 years at 5%? So many professionals use sensitivity analysis to help make several common business decisions, such as determining break-even points based on different assumptions. So again, for this sensitivity analysis, spreadsheet software such as Microsoft Excel is a common tool for performing the sensitivity analysis. This is the example which shows the Excel file created to quickly show the break-even point. This is the break-even point now you can see here. point for a product based on various inputs. So the sales per unit, here you can see these are the inputs. The sales per unit, the manufacturing cost, the cost per unit, and the fixed monthly expense. These all are the inputs which help us to calculate the break-even point. So the current inputs results in break-even point of, with these values, you can see the current break-even point for unit sold is $6,250. Unit sold. So we can have unit sold, so we can get the break-even amount of $75,000. So users of this spreadsheet can change inputs and see the effects on the break-even point in chart format, and the project team often creates similar models to determine the sensitivity of various project variables. For example, Cliff's team could develop sensitivity analysis models to estimate their profits on jobs by varying the number of hours required to do the jobs or by varying costs per hour. So all these steps for the quantitative analysis are important for to know the status of our project or to take the to evaluate the risks. Let me show you now the Excel sheet for this break-even example. So this is the same example which we see in the slides, and you see we have three inputs: sales price per unit, manufacturing cost per unit, fixed monthly expense. So if we change the values of the inputs, we can see the break even. For the current values, sales per unit is $12 and manufacturing cost per unit is $8 and our fixed monthly expense is $2,500. So for this, the break even point is 6250 units so sales we can get, which is $75,000. So maybe I change the sales per unit, change the value, and you can find out the break-even point is also changed. Of any inputs, if we change, we can have the values of the break-even will be changed. So here you see the Excel is a very good tool to find out, is a common tool for performing the sensitivity analysis. So this is how all about our today's lecture. We are done with two important approaches, qualitative and quantitative analysis. And in both the approaches, the qualitative approaches, we need to update the risk register such as our ranking column. So we can use sensitivity analysis to study the specific outcome based on various project variables sensitivity. For example, to study the schedule, consequences, and as well as the cost sensitivity. So here we are done for today.